Hello everyone, welcome to robotics class once again. In last class, we have studied about the link parameters, we have studied about joint parameters, we understood what is twist angle of a link, we understood how to calculate length of any link, we understood how to calculate joint distance as well as joint angle. We became familiar with the terminologies like AI, alpha I, DI, theta I. So, all four things or all four terminologies we have studied in last class. Today, we will much focus on DH notation or Denavit-Hartenberg's notation. Before knowing that, there are some prerequisites. We need to know the concept of direct or forward kinematics, as well as we have to know the concept of inverse kinematics. What happens? You can see this model. In this, we have kept direct kinematic model over here, or like forward kinematics over here. We have kept inverse kinematic model over here. We have connected both these two with joint and link parameters, and we have kept position and orientation of end effector as well as joint variables. Remember, this position and orientation of end effector, this one and this terminology joint variable, both are acting as either input or output. Sometimes we will give, or the joint variables will be known to us. We need to determine the position and orientation of end effector. Sometimes the position and orientation of end effector will be known to us. We need to determine the joint variables. So, in order to find out these two problems or these two things, we need to go for either direct kinematics or forward kinematics, or we have to go for inverse kinematics. Now, joint and link parameters already we have come across. We know that AI, alpha I, DI and theta I, those four are joint link parameters. In case of direct or forward kinematics, we will be given the joint variables, and from there we have to find out the final position and orientation of the end effector. In case of inverse kinematics, we will be given the position and orientation of the end effector, and we finally have to find out the joint variables. The same thing is represented in this table. Like in case of inverse kinematics, we are taking input from here and output we are getting here. In case of direct or forward kinematics, this is only the input, it is coming through the direct kinematic model, and finally we are finding out the position and orientation of end effector. So, this is about direct and inverse kinematics. Moving forward, we will have to know another one thing, that is how to represent or how we have to calculate the value of AI, DI, theta I and alpha I. So, same diagram which in last class I have shown, we have brought here. We are going to show few more things which will be added along with the previous diagram. So, we got link I minus 1 and link I like previous case or previous class or we have studied. Then we have got three axes, that is axis I minus 2, then here we have got axis I minus 1 and here we have got axis I, right. Now, next we will get three joints which we found already in last class. So, this is joint I minus 1, here we have got joint I and this will be joint I plus 1. Now next, we have chosen the same plane so that you will be understanding what is actually happening here. We have to find out the joint parameters and link parameters. We understood that the common normal between axis I minus 2 and axis I minus 1 will be represented as the length of the link I minus 1. So, a I minus 1, as you can see here, a I minus 1, that is the length of link I minus 1. Similarly, we found out the length of the link I, as you can see here. So, for that also we have found out the common normal between axis I minus 1 and axis I, which is represented as AI. Similar to the previous one, we found out the joint distance, which is represented by DI. The distance is the distance between both the common normals, and also we found out alpha I, as you can see here. Similarly, we found out theta I, as you can see here, and then we have to give or assign some name of frames. We have to follow certain procedures. There are some steps which we need to follow. So, before that only we need to assign the number of frames. You see here in this case, here at point B, see point A is what? Point A to point B, this is, if we join these 2 points, then only we are going to find out the common normal between axis I minus 2 and axis I minus 1. So, at point B we will get some x axis, y axis as well as z axis. You are already taught that if we are rotating, as here this is we have got some revolute joint or rotary joint, that is why along axis I minus 1 only rotation will take place. That is why this will be our z axis. If we are considering any frame along this axis, that will be z axis of the frame. We have considered at point B we have got frame I minus 1, and at point C we have got frame I dash, and at point D we have got frame I. Here I have not mentioned, but we have to bring from here to here, that means B to C, and then we have to bring it to D. Okay. So, at point B we have got frame I minus 1, at point C we have got frame, so not point, frame I minus 1, and here we have got frame I dash, and here at point D we have got frame I, right. Next, now I will omit all these things, this portion I will omit, and we will see how actually it will look. Remember one thing, we are supposed to find out the link parameters and joint parameters, as already discussed. I said you that there are some way or method to find out the link parameter and joint parameter. In link parameters, we have got link length. So, link length is nothing but the distance along xi axis. That means, along xi axis we have to find out the distance, and that too from the point of intersection of xi axis with zi minus 1 axis to the origin of frame 1. So, that is how we need to find out AI. The shortcut is we have to find out the distance along xi direction or along xi, and it will be from frame 1 or origin of frame 1 to the intersection between zi minus 1 and xi. If we go back to the previous diagram, I will just show you. In this case, for this point or this case, we are finding out distance. AI is along this direction. Okay, AI is along this direction. So this direction is what? This is x direction. Already I discussed that here we are rotating about z axis, or this is the axis of rotation. That is why this will be z axis. Now, if we are considering ith frame or I minus 1 frame in this case, this is I minus 1 frame. If you consider here at point A, it will be frame I minus 2. Okay. Now, from here we found out the intersection of x I minus 1, that means again it will be in this direction only, and z I. So, this is the z I in this case. So, both these two are interacting here. So, from here to here we have to find out distance in order to find out AI value, right. So, that is what we did. So, we will move back once again to the table. Now, if we are going to find out the link twist or alpha I, that will be in simple form the angle between zi minus 1 and zi. That means, if you are going to find out the link twist, so you will have suppose one link, suppose this is one link. So, here we will have one joint, here we will have one joint. So, here we will draw one axis, here also we will draw another one axis. So, if we consider this one as 0th frame and this one as frame 1, so in frame 1 we will get one z axis, that will be z1, and in frame 0 also we will have one z axis, that is z0. We have to find out the angle between z0 and z1 to be so this is the angle, that is what we have written here, zi minus 1 and zi angle we have to find out. So, this is about link parameters. In order to find out the joint parameters, we need to find out joint distance as well as joint angle. Joint distance di can be found out by a distance, or considering the distance along zi minus 1 axis, and the origin of the counting of the distance will be I minus 1th frame, or origin of I minus 1th frame to the interaction or intersection between zi minus 1 and xi. So, in previous case also we found out, we had to find out the distance from the origin of frame 1 to the intersection of, or intersection between zi minus 1 and xi. Here also same thing we are doing, we are finding out intersection between zi minus 1 and xi, but the origin will be the from we have to find out the origin of zi minus 1, or origin will be of frame I minus 1. And if we are going to find out the theta I, so how to find out theta I? It will be the angle between xi minus 1 and xi. In case of alpha I, we had to find out the angle between zi minus 1 and zi, but here we have to find out the angle between xi minus 1 and xi. So, these are the 4 rules we have to follow once we are drawing the diagram of in case of DH notations. Now, you remember the previous diagram? I hope you remember the previous diagram. So, in previous diagram I said already that those two links we have eliminated and we have kept only the axis and its notations. So, if we are doing the same thing here, then we will get the complete information over here, where we have got zi minus 1 axis here and we have got zi axis. So, axis I, in this z will be the direction or axis of rotation, that is why here this is zi Similarly, in this case also, this is axis I minus 1, and along this direction only rotation can take place. So, this is nothing but Z I minus 1 direction. Now, you can see here, this is x I minus 1, and once we have moved to here, it is x I. Our intention is somehow, or we have to follow some steps so that frame I minus 1, okay, we have already studied in previous diagram, frame I minus 1 and frame I both will coincide. That means the z axis of frame I minus 1 will coincide with zi, then xi minus 1 will coincide with xi, and similarly yi minus 1 will coincide with yi. So, you can see that this axis is our yi minus 1 as I have represented here. So, this will be coinciding with yi, that is what our intention. For that, we have to follow few steps. Step number 1 is what? We have to rotate the z axis of frame I minus 1 about an angle theta I. You see here, we have got theta I over here. You can see that theta I is here. Okay, this is theta I, and this angle is theta I. If we want this one to move at this place or here, then first of all we need to move it somewhere here, then we need to bring it here, and some angle also we have to rotate if it is required. Then that is the reason why first and foremost we are rotating this xi minus 1 at some angle theta 1, and we have to rotate about zi minus 1 axis. That is what is written here. That is the first step of us. So, once we perform it, what will happen? This xi minus 1 will be rotated here. So, here we will get this along this direction we will get xi minus 1. So, that is number 1. Second is what? Once we have coincided with this one, we have to move frame I minus 1 to here. That means at I dash frame. By how much distance? By exactly di distance, as we have seen already. So, if we are moving by di distance, then the frame I minus 1 will move here, as well as the x axis of I minus 1 will also be in this direction only, as you can see. So, second step is done. Step number 3, again what we have to do? We have to move, now the frame is here, we have to move it along this direction. That means we have to translate it. What is this distance? This distance is ai. So, by ai distance we have to move it, or we have to translate it. So, is the work over? It is not over yet. We need to, so if we are bringing here, what will happen? Z will be in this direction only. X is in this direction, no problem. We got x, but Z has to be rotated by some angle. How much angle is this? This is nothing but alpha angle. And how we will get it? If we rotate the x axis by an angle alpha I, then only Z will come from here to here. That is the reason why you can see here the fourth step, T, transformation, not translation, transformation, okay, and we have to do some rotation by an angle alpha I, as you can see, about axis x. So, these are the 4 steps we have to follow in this case. If we follow these 4 steps, then what finally we are going to get? So, kinematic relationship, if we are going to find out between those two adjacent links. So, we have moved frame I minus 1 to frame I. For that, what we did? We have first rotated the z axis of frame I minus 1 by an angle theta I. So here we have written the same thing. Okay. In this case, we are going to follow pre-multiplication. It means left to right, not right to left. Okay. So Tz was done. That means it can be also represented as Rz, can be represented as Rz. Okay. And theta R, you can even write Z I minus 1, that also is more specific, and by an angle theta I. Secondly, what we did, we have translated the frame by a distance di, at that too along z direction only. So that's the reason why we have written Tz in the second one. That means along z direction only we have translated, or we have moved by a distance di. Third one, what we did, we have moved the newly generated frame or frame I minus 1 at a distance ai along x direction. That's the reason why Tx we have written here. So as we have moved or we have translated along x direction, that's why it is written Tx. By how much distance? Ai, that's why we have written ai. Finally, what we did, we have rotated the x axis of that frame by an angle alpha I, that's why Tx is written. That means some transformation we did about or along x direction and by an angle alpha I. Okay. Now, we already are known about the 4 by 4 transformation matrices. If we are rotating about z axis, what will be the rotation matrix, as well as if we are translating only, not rotating, then what will be the 4 by 4 matrix, or homogeneous, if we are going to find out homogeneous matrices, then what will happen? Similar way, if we are doing or performing both rotation and translation, then what will be the 4 by 4 matrix form? So all these things we have studied. About z axis, if we are rotating, then what will be the matrix? About y, about x axis also, if we are rotating, then what will be the final outcome? We have already studied. Now, here you can see, first one, what we did, this is the homogeneous transformation matrix if we are rotating any frame about z axis by an angle theta 1 or theta I. So that's what is mentioned here. Now, second one is what? Second one, we did not perform any rotation, that's why we have written 1 1 1 in this place, and we have moved along which direction? Only along z direction by an angle or by a distance di. That's why dx value is 0, dy value is 0, dz value is di, right? If we are translating along x direction, then we have to put here. If we are translating along y direction, then we will keep something here, otherwise these two values will be 0. And what is this one? One is the scale factor or the value of sigma. In third case, what we did, again we have performed translation along x direction. That's why you see here, as we don't have any rotation at all, so we have kept this 1 0 0 0 1 0 and 0 0 1, and we have translated the frame along x direction. That's why here dx value is ai, okay, and dy value is 0, dz value is 0, as we have not done any transformation along y and z direction. And similarly here also we have got the one value, that is the value of sigma or scale factor. And at the end you can see we have rotated the frame at an angle alpha I about x axis. So that's why we have written here. So here this theta form is replaced with alpha I. Now if we perform the multiplication, you will finally get this value, which you have to remember. This is very important derivation, for your DH notation or DH problems, we have to remember this form. This is very important one. With this, I am finishing today's class. In next class, DH algorithm I will discuss with the help of a problem. Thank you.